In this video, we are going to talk about the program scan. And for the program scan here, it's related to how the processor of PLC will execute the PLC program. So during each program scan cycle here, which is actually the running of PLC is continuously, so it consists of a sequence of scan cycles. So usually the processor reads all the input data, take the value from input devices, and energize or de-energize the output device according to the received data and according to the program saved inside the memory. Okay, so if we go through this cycle, which is very important to understand how the PLC system will work, when we start to run the PLC, actually it will scan all the input device. So when we say input device means either discrete or analog. We means switch or sensors. Okay. So all the device will be scanned for the device which connected to the input modules will be scanned to check their status. Okay. Is it switch on? Is it switch off? It's give you 0, give you 1, 10, 100, and so on. So it will read all the values of the field condition. Okay, and this data actually will be saved or will be copied to the input image table that we see in the previous video. Okay, so to the input image table. After that, after it's read all this data, it will compare or solve the software that we have, which is consists of several instructions like this one: instruction input, instruction for output, and so on. So it will compare the input data and solve this software based on the received input data. What will be the decision or what will be the action that will be taken to send to the output? Okay, so each ladder rank here is scanned and solved using the data in the input files. The resulting logics will be writing to the output image. Previously, in the previous video, we highlight two type of image file. We said input image table and output image table. So after the processor will scan the input and compare with or solve the software inside it, it will send the output to the output image table. Okay. Then we come to the output scan here. Output scan, the output image table here or data will be transferred to the output modules. Then from the output modules will be sent to the output devices like actuators. When we say actuator means either pilot light, either motor, servo motor, stepper motor, and so on. So this data will be sent to the output, and the status of the output will be changed depends on the data that we receive from our controller of the PLC. Then housekeeping. So in the housekeeping phase here, internal check will be conducted for the memory, for the speed, for the operation, communication request, and so on. So that means it will be check the overall functionality of our PLC, and it will be repeated again the next cycle. So again, start, scan input, program scan, output scan, housekeeping, and so on. So this will be the cycle will be running continuously. If I ask you about the cycle of PLC programming, you should explain these steps actually, how the PLC will run our program. Actually, the program already stored in the memory, but also the input device connected to the input module. The output device will be connected to the output modules. And when we talk about the software part, that means we are going to see this scan cycle of our PLC program. So the time that will be taken to complete one scan, it depends on how fast is our controller to process the data, or how big is our program, how many rank need the PLC to complete in order to reach to the end command at the end of the program, and so on. So if a controller has to react for one input signal that will be changed twice during one cycle, that means the PLC will cannot read the second reading. Okay, so I mean within one cycle only the PLC can check one status, then in the next cycle it will check the other status, and so on. Okay, so depends on the long of the cycle or of the scan cycle here is depends on how many devices we have, how big is our program, how fast our processor or controller can process the received data from the input devices. So the scan time here is a function of the speed of the processor module, the length of the ladder program that we have. When we say ladder program consists from different ranks. In the first rank, what we have in the second rank, and so on until we reach to the end rank. Then the type of instruction. So if you have a normal instruction, which is examine if open, examine if close, uh, execute or switch on control relay, and so on. So this some simple instruction which will not take a long time. But if you have some instruction which is more on the counter, timer, and other complicated instructions, so this will be take more time. Or if you have a loops and so on, so this will take longer time. So we say here the type of instructions that will be executed. Then the actual ladder true false conditions. So sometimes we have the status of, if I said examine if open and the status is open correctly, so the status will be true. For example, examine if close and the switch is closed, so it will be true. So depends on if is the instruction is true or false. So this will be also affect the long the time of our cycle. Okay, the BLC components here or the BLC computes the scan time each time the end instruction executed. So we said when we have the start of our cycle for scanning, it will end, and when you reach to the end instruction usually we use it at the end of our program. So every program must be end by using end instruction, and this end instruction will show you how the program will be or when the program will be ended. Okay, and it will repeat to the next cycle. Typical scan time here that include the maximum scan time and the last scan time. So usually, I mean, as fast or when our controller complete the scan faster, so it will repeat the scan process fast than if the if the scan process takes longer time. Okay, in a rank here of hardwire circuit, there must be electrical continuity. So when we say electrical continuity, we already have one example in chapter 4, show how the process control of of the tank and the heat or the temperature inside the tank and so on. So we said if your instruction give you true, then the output, if the input are true, the output will be true. If one of the input is false, yeah, then your output will be false. So the main part to execute an output or to give you an output, you should have true continuity or electrical continuity from the left side to the right side. So if you have here three instruction, limit switch or limit switch one, limit switch two, and you have here solenoid output. So since these are continue in or connected in series, so that means this ls1 must be true, ls2 must be true, then sol will be true. Otherwise, if ls1 or ls2 are true while the other is false, so this will be false. Okay, the rank has electrical continuity only when the current flow is established in the path from one side to other to the power rail to the other side. So we start from L1 until we reach to the L2, from the left to the right. So this is the direction of electrical continuity that will be should be achieved in order to give you an output. The PLC ladder logic is evaluated in terms of logical continuity here. So we can see here the status of the instruction inside your software or your program or ladder logic program will be indicate the status of the real device. So for example, here we have this switch number one. The status of switch number one is closed. As you can see here, is switch one is closed or connected. So you can see the status of the rank in condition and rank out condition for this switch or for this instruction. For S1 is green. So it's active. That means there is continuity. There is this condition is true or this instruction is true. For that, your output also will be green here. So it will be output instruction will also be true. So since the output instruction is true, the output device will be lighting on, for example. Then the second one here, we have another switch. This switch is open or off. There is no continuity here. There is no, it's not active. So that means this switch or this instruction is false. Since this instruction is false, the output also will be false, so the output device will be off. So I mean, in order to have energized status for the output, you must have active output condition or output instruction here. Okay, so this is active, so this will be energized. This is inactive, so this will be de-energized. Okay, this is how the data will flow during the scan process. As we said, the data start, the first point of the data come from the sensors or switch. So this come from the sensor and switch, go to the input modules. From the input modules, it will go through the input image table that we mentioned before. From the input image table will be examine the program inside the memory. So the data will be the input data will be compared with the real or with the existing program or instructions. Uh, for based on this instruction, the status of the output instruction will be updated based on and then it will be sent to the output image table. From the output image table, it will be sent to the output modules. From the output modules, it will be sent to the output devices. So this is how the data will flow from the input devices to the output devices. This scan process applied to a single rank program. When we say single rank program, that means it consists from one rank only. There is no parallel rows here, no mini rows. It's only one rank. So this rank consists from two instructions, one for the input at the terminal slot number 3, terminal number 6, and the other instruction output at slot number 4, terminal number 7. Okay, so you can see this is the input terminal, and you can go for the terminal number 4. I mean terminal number 6. You can see the this is slot number 3, terminal number 6. It's connected with one device is here, and the input device here, the status is closed actually. This input device go through the module. From the module, go to the input image table, then go through the program again to the output image table, to the output module, then go to the output devices or to the field device. Okay, so as you can see here, input devices number 6, terminal number 6, go to the input image table. This is in the case that you have only single rank. If you have multiple rank, also to be the same. So the status or the steps or the data flow here will start from step 1, read the input device model. After you read the input device model, after the input device model read the data, will send to the input image table. From the input image table here, it will solve the ladder logic program rank by rank, start from the first rank, second rank, until reach to the end rank. Then it will send the data or the output to the output image table. From the output image table, it will be transferred to the output model. After output model, it will be sent to the output devices and so on. So this is the normal scan of the program inside the memory of our PLC system. The vertical versus horizontal scan pattern here, since we have, when we said we have multiple ranks, that means you have several rows here, 1, 2 rank, 3, and this is sub rank. So all this rank, actually, the data or the program will execute it. First, it will execute one row, then go to the next row. So first will be horizontally from left to right, then it will go from top to the bottom. First is horizontally scan from left to right, then vertical scan from top to the bottom. Then it will be repeat again to the first step. Okay, so this is how the sequence in case you have multiple ranks for your program of PLC or ladder logic program. It will scan first from the first line or first rank from left to right. It will check the continuity of electricity. Then it will go next to the second, the third, until reach to the end of ladder program. Then it will repeat again to the top. Okay, cannot go directly from the second rank or the third rank. No, it should be from the first and the top until the end, then it will be repeated again. Thank you. I'm going to continue in the next video.